Ugh. I even have a ruler. I have a ruler sitting right next to me. Did I use it? Nope. I had to tell Penny this morning that Daddy was gonna come pick her up from daycare. She was like, but why, Mom? Why did we wake up so early this morning? And I'm like, well, you and I had to leave the house at like 6 a.m. because you and I had to go get donuts from Blados so that we could give them to Math League. And she's like, oh, is that why you're not picking me up because you have Math League after school? And I was like, yes. And then right after Math League, I have to do drama practice until 8 p.m. And she's like, why are you doing these things, Mom? And I'm like, I'm not quite sure. That was a little deeper of a question than I wanted to hear this morning, actually, Penny. So shush. Shush, 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 shush. I have what flipped? Right, this one's a tall triangle with 30 on the bottom. This time we're referencing 30, right? Or 60 on the bottom. So now what are the sides? It's the exact same triangle. This is the exact same one. Exact same triangle. It's just turned and flipped. Yes, because this hypotenuse is still 1, right? So what's this height now? No, this little side was the half, so where's the half now? The half is on the bottom, and this side is? Good, the square root of 3 over 2. This is kind of where algebra and geometry meet this class. All right, so now I'm going to write out my point up here. So did you do this with Thorson, where he explained where this stuff is coming from?
No, we just.
You just use the unit circle.
Yeah, and they told us the XY thing. That's what I remember that.
Yeah?
Would you just put the points on the
Yes. So this one's 1/2, and this one's the square root of 3 over 2. All right. Can you see where that third triangle is going to come in here? Now we're going to do a 45-45 triangle, and this is where we're going to use a different color, okay? Because do you understand why I use the same color for both of those triangles? Because they're really the same triangle. But now what I want you to do is I want you to go back up to that 45-45-90 triangle, and I want you to color it your last color, whatever that is. I've got kind of a really classy poop brown going. Drawing your last line here. Hopefully this thing is starting to look kind of cool. What? My second color is brown, but yeah, if yours is red, then. All right, now this one's a little harder. It'd be really easy if the sides were 1, right? But it's not. The hypotenuse is 1. So I'm going to draw a new triangle on the bottom. I should make it look like the one that's in the unit circle. Actually using my ruler this time like a winner. Here's my right angle, here's that 45 degrees, 45 degrees. What's the hypotenuse always in a unit circle? All right, now that's 1. Now the problem is, it'd be really cool if the side was 1, because then this problem would be so simple, but it's not. If you look back at this original example, do you see how it was 1 is now x times the square root of 2? Gross. Oh, gotta make it poop brown, right? right, so I'm gonna write here, 1 is equal to x times the square root of 2. So how do I get x by itself? Divide by what? No, I'm trying to get x by itself. I'm trying to get rid of everything else.
Divide by square root of 2.
Divide by the square root of 2. Okay, have I told you about that stupid rule how you're not supposed to have a square root on the bottom of a fraction?
Ignore it.
No, we're not ignoring it. And the reason why is because this is going to keep popping up constantly in college. So you got to know it. There's lots of stupid rules in mathematics, and this is one of them. I mean, this is a really stupid rule. Like, it makes sense that you can't have a negative under a square root, right? Because two numbers can't multiply by itself and equal a negative. That makes sense. And it makes sense you can't divide by 0. Because how can you split something into 0 parts? But this one is honestly, it's just like a... It's like they want the math to be equal across the boards. They made this rule so that all mathematicians do things the same way. It's kind of like, you know how mathematicians always, they go like the highest to the lowest, so it'll always look like this instead of like x plus x squared plus 6. They always go highest to the lowest power. So this is called rationalizing the denominator. If you have 1 over the square root of 2, here's how you rationalize it. You're just not supposed to have a square root in the bottom of a fraction. So you multiply by the square root of 2 over the square root of 2, which is the same thing as what? 1. And you can multiply anything by 1. What's 1 times the square root of 2? The square root of 2. And what's the square root of 2 times the square root of 2? The square root of 4, which is 2. You see how that gets rid of the square root on the bottom? That's how it always works. We're going to be rationalizing the denominator like a stupid amount of times. You're going to just do it like automatically pretty soon here. And it's always whatever this is, just itself twice, and then it turns out like that always. So this side is the square root of 2 over 2. And this side, since it's an isosceles triangle, is also the square root of 2 over 2. Which means that this side, this is now the square root of 2 over 2 and the square root of 2 over 2. Now, is anybody anticipating that this is going to be a nightmare because we've only done 1/4 of the circle? The rest is actually really easy. Why? Now you just think about positives and negatives. Do you see how this is all symmetric, right? So this angle right here is the same as this angle right here. So tell me, what's the difference between quadrant 1 and quadrant 2 as far as positives and negatives? The x is negative now. Is the y still positive? Yes. All right, so you're going to copy the exact same points over symmetrically. You're just going to make all of the x's negative now. Because cosine is x and sine is y.
Did you make like the square root of 3 negative? Or
You mean on this one?
no, for the other one, the top one.
You can't see them.
No. So it's not negative?
No, just the x's are negative.
Oh yeah, because it's
What'd you say?
Is it the square root of 3 and x? Or is it just that if you make that negative 2, then it's actually a positive? Wait.
So the x is the left value, right? So all of those go negative in the second quadrant.